Very good morning to all of you. So we are going to do some numericals asked in previous exams, and we will solve some numericals in this lecture. Okay, so suppose we have a question here. A complex function f of z is given by under root z plus 1 upon z minus a plus exponential of z. So when you see this question deeply, you will get that z equal to a is the pole of order 1, and we are expanding it e raised to the power x 1 plus x plus x square factorial 2. So you can clearly see it has pole also, and it has essential singularity 2. So S is a pole, a branch point, and singularity. All of three are true. Now, which of the following correspond to under root iota, where iota equal to under root minus 1? So you know z equal to under x plus iota, z equal to x plus iota y, and it is saying under root iota. So under root iota equal to under root x plus iota y, square it, and you are having these two equations. So from here you got x equal to y and xy equal to 1 by 2. So put x equal to y here, and you are getting y equal to under root 2, which is equal to x. So under root iota will be 1 upon root 2 plus iota 1 upon root 2. So option A will be correct. Now we have step function here. We have to calculate the value of this integration, and our closed contour is this C of circle of radius A at center 0, 0. So z equal to 0 at simple pole. So 1 upon 2 pi iota is here, and the value of this integral will be 2 pi iota times of function of 0, which will be 1. Again we have a question here. Function of z equal to 1 upon z square plus 1. It is a semicircle from minus 2 plus 2, and radius is 2 origin. So we have singularities here, z equal to plus minus iota. So only z equal to plus minus iota will be problematic point. So you know how we'll solve it. 2 pi iota into sum of residues. 2 pi iota limit z tends to minus iota, and z minus iota by z minus iota will be cancelled out. 1 upon z plus iota will be in numerator, and we will find out its value on z equal to iota. So we are having answer pi. Very easy question. At z equal to infinite, complex function f of z is a singular point. This is the same question we have discussed above. 1 upon z square plus a square, a is greater than 0 for contour. Real axis semicircle of infinite radius. So here two singularities will be here, plus minus iota. Only plus iota will be problematic point. So we'll write down is phi z upon psi z. So plus z minus iota will be in denominator. It will be cancelled out in the limit. So only 1 upon z plus a iota. Put z equal to iota, so we get 2 iota. And we know integration equal to 2 pi iota into sum of residues. So pi by will be answer. Now same function with z square in the numerator. So again plus a iota, so z minus iota will be in denominator, it will be cancelled out. Z square upon z plus a iota. So simply put, z equal to minus a iota. You are having residue minus iota a by 2. It is the residue. But if you calculate the value of integration, then 2 pi iota into iota a by 2, so equal to minus pi a. Here is the function. So x equal to plus minus a at a prominent point, and it is 0 to infinity, but we define minus infinity to plus infinity, so it will be 1 by 2 of this integration. So at z equal to plus a at a prominent point, so same 2 pi iota and sum of residues. So 2 pi iota and sum of residue is z minus iota cancelled out, and it will be left out in numerator. Put z equal to a iota, so e power e raised to the power plus a square, and 2 iota will be in denominator. So it is explained here at pi by 2a e raised square. So solve it. Z bar equal to x square plus y square. Put it here, expand it. You are having this. Now here answer should be like this. Means you are getting this equation from solving these equations, but from here to here what will you do? Half of the coefficient of x, this is 2 square plus and minus. So minus 4 and plus 4 will be there. Similarly minus 9 and plus 9 will be there for this part. So it will lead to you this equation. So you are having x equal to minus 2, y equal to minus 3, and radius equal to under root 10. So you know, we have studied it. It is the Laplace equation basically in LCT. Very easy question. It is the basic formula: e की power x plus cos bx dot cos bx dx. ये power sigma square plus b square plus a cos bx plus b sin bx. So simply put, infinite by 0, so whole term will be 0, and minus a0 will be 1, and this, and minus b plus a cos 0 will be 1. So we'll get a upon a square plus lambda square. You know this very easy equation, pi by 2. Simple close conclusion z0. So you can see it is pole of order 2. So pole of order 2 include, so pole of order more than 1. If it is less than 1 or 1, it is multiplied by function of that value of the function at that point, multiplied with 2 pi iota. But for this, what we'll do, 1 upon factorial n minus 1 d n minus 1 upon d z n minus 1 function of z at that point. So here pole of order 2, so d factorial d by dz. Very easy question. At infinity it will be goes to minus 1. Again see, close contour z equal to 1, so it will be 1 minus 1, and z equal to minus 2 will be outside of the close contour, so value of the integration is 0. Again phi z upon psi z, so when you put limit, it is pi x upon psi prime x first derivative, so it will lead to 1. Is simply p series, 1 upon n raised to the power p, and if p is greater than 1 it converges, and p less than 1 it diverges. Same question we have done it earlier. So we have 4 points here, plus minus iota, plus minus 2 iota, and only iota and 2 iota lies inside the close contour C. So calculate z equal to 1 iota and z equal to 2 iota. Limit z tends to iota, z minus iota, it will be cancelled out. Put z equal to iota in this function, you are having minus 1 upon 6 iota. Similarly for z equal to 2 iota, limit z tends to 2 iota, it will be cancelled out. Put z equal to 2 iota here, so you are having 1 upon 3 iota. value of integration is 2 pi iota and sum of residues. So it will lead to under pi by 3. Now we have a function, so you can see u is here and v is 0, u plus iota v, not term in complex part, imaginary part, so it will be 0. So when it is satisfying the Cauchy-Riemann equations, simply this part, but does it have limit, defined limit? So in order to calculate limit and its differentiability, well, what will we do? We will find its f prime 0 minus dy by dx. So limit z tends to 0 f z minus f of naught by z. We are left with this. Put y equal to mx for a line on curve. So you can see here that limit defined on the slope. So limit is not unique. Okay, so it is not analytic. So there is a question here. What it is saying? It is a complex number z, and when you multiply it with iota, what will happen? We can write down it like this. Why? Because it will expand like cos theta plus iota sin theta. So cos 90 will be 0 and sin 90 will be 1. So it will be give you iota. So it will be it will multiply with the whole term. So z, if z is like this, so iota z can be written as like this. So you can say the argand of this complex number is theta and the argand of this complex number is theta plus pi by 2. So when you rotate it with pi by 2, the whole complex number is multiplied it with iota. Very important question. Again, residue. So z equal to a iota. So z if we cancel out, put z equal to a iota here and you will get residues. So most of the time you will get simple question to calculate residue. You can calculate it directly, but sometimes the value of integration will be asked and you have to do 2 pi iota sum of residues. So there are certain ways we have studied. So first look at the question and determine which approach is going to take less time and give you accurate answer. In order to choose among those four options. So to be analytic, z equal to plus minus 1 for hyperbolic complex function. So we have to calculate this value, and this is the circle of radius 5, 2, 0. So 2, 0 circle of radius will be 7 and circle of radius 5 and center is 2, 0. So here is the center 2, 0, and if circle is radius of 5, then 5 radius from here will be 7 and 5 radius from here will be 1, 2, 3, 4 and 5. So I think we have drawn it wrongly. It will be very big. Okay. Now we have to calculate residues at z equal to 3. So limit z tends to 3 and it will be 1. Give you 1. But you have to draw it again. Okay, I will do it. Now it is correct. which of the following function is analytic function? All polynomials are analytic function, and z bar is never can be analytic because complex function. So just remember it. It is the Bessel function of first kind. In special functions, we have studied it. There is separate playlist on our channel. Okay. Separate playlist is there named with special functions, and we have written it there. Again, same question. Z equals to 100. Unit circle. Anticlockwise. So just expand it. And residue is multiplication of 1 by z. So 1 upon factorial 2. So 1 upon 2 and 2 pi iota pi iota. So you can have approach like this also. Okay. You don't always have to calculate like we explained earlier. Sometimes you can just expand the function and get the coefficient of p1, and you will have the residue. So just simply look at the function and try to find out the simplest way and most least taking time way to solve the question. It is the green function. We have not studied green function yet. Some questions are for practice. Just do it. So these were some questions I have explained. Thank you for your participation.